Hello, in this lesson we're going to talk about the simple pendulum and the concepts behind its movement. So stay tuned until the end for you to understand why it's important to study the simple pendulum. Okay, so let's first understand the simple pendulum and its movements. Alright, so here we have our simple pendulum. We have a displacement angle, the length of the wire, the mass of the ball here, and S is the path it does. Okay? Let's try now to understand the forces that are acting on this ball, on this pendulum. Okay? So we have the weight, right, pointing down. We have the traction of the wire, alright? And we have a net force that's pointing into this direction. So the ball moves into this direction when we displace it to the right. Okay? So the traction is actually an elastic force, right, due to the wire. So it's a negative times k, the elastic constant, times the displacement. And for the weight we have mg, right? Now the net force, we can take a look here and take the wire here as our reference, alright? So the force is actually a component of the weight. It's mg sine of this angle, the displacement, right? Just one thing, let's consider now very small angles, and by small angles I mean like less than 15 degrees, right? For small angles like this, we have that the sine of the angle is actually approximately the angle itself. Okay? So we can simplify this formula to negative mg times the angle. Also, for small angles here, we have that, well, the angle here is actually S divided by L. Okay? This in radians. Alright, so we can now insert this into the formula, and we have an equation like this. F, the net force, is actually negative mg over L times this S here, the movement, okay? If you take a closer look, it actually looks like an elastic equation like this, where we have a negative times the constant, which is mg over L, times the displacement, which is S, okay? And well, we're dealing here with a harmonic movement, right? You can check out our video on harmonic movements, alright? The simple harmonic that we have here in the channel to understand it better. But when we talk about the simple harmonic movement, we can talk about period. And so we can calculate the period of the pendulum, okay? I'm using the letter P here, just not to be confused with the letter T here from the traction. Generally, just for you to know, generally we use the letter T for period, okay? But here I already used the letter T, so let's use P for period. We can calculate the period with this formula here, 2 pi times the square root of m over k. We can change this k here for our constant, okay? And we have the formula for the period of the pendulum, right? Which is 2 pi the square root of L over G. It's interesting to notice that it does not depend on the mass here, nor the angle. So for a simple pendulum, if we have small displacements angles, okay, it does not depend on anything else, just L, the length of the wire, and the gravity acceleration, okay? And it's very, very useful to us, this formula here, the small pendulums, to calculate the gravity acceleration in any point on Earth. So let's take a look into a very practical example for you to understand it better. Alright, so we want exactly to know the acceleration due to gravity in a region where a simple pendulum having a length of 75 centimeters has a period of 1.7357 seconds. Okay, so let's go. We can just simply calculate it for small angles with a small displacement of this pendulum. Okay, calculate the gravity acceleration. We already know the period and the length of the wire, okay, the length of the pendulum. So we can just add the values. Let me square both sides, okay, and add the values for G. And we have that G is actually 9.8281 meters per second square in this region here. Notice also that this for these small angles we have a very precise. We can calculate the gravity very precisely, okay? Because the error is generally less than 1% for small angles like this, and this is exactly how the old equipments we had to calculate gravity used to work. It was simply a simple pendulum, and it was very useful, okay, and gave us really precise measurements of the gravity acceleration, okay. All right, now it's your turn to think about it, okay. Consider two pendula, both 2 centimeters above the floor and displaced by 12 degrees, okay. The first pendulum has a bob with a mass of 10 kilograms and the second one with a mass of 100 kilograms. So I want you to think about this situation and describe how the motion of the pendula differ, okay? If there are any differences in the motion of these different pendulums, okay? Think about the formula here of the period and give your answers in the comment sections. Thank you very much and see you next time.
What did you think about this video? We appreciate your feedback, so tell us in the comments section.